So here we go. What we want to do today is just to introduce and review some Desmos activities that are suitable for grade 11 and 12. I know this is very broad because there's a lot of grade 11 and 12 courses. So today we're focusing a little bit more on the 3U, on the 4U, and a little bit on the calculus. One of the collections that I sent earlier, today, we sent 2 collections for grade 10 plus. And within those, there's a lot of room for us to use content for MAP4C, for MEL, for courses that are college and workplace bound. So today is a little bit more on this sort of topic, okay? So we're going to talk about how to provide student feedback directly in an activity. You can do that in Desmos. This is one of the new features, which is fantastic. You can now connect with kids and immediately give them feedback as to what's happening. We can show you how to run an activity live so that it could be kind of your entire lesson. When we're talking about these 3 hours, these could be an entire lesson that you can begin or get to a certain point and the students complete. And the benefit, of course, is that you have all the information of the students who participated and what they accomplished or not. And I had here to share 2 collections of activities. That is not true. We share 3 collections. Technically, we share 5 collections for you today. And of course, to have a bit of fun in the process. So we're going to start by playing with one of these activities. And for the first little bit, I need you to come along and be a good student. So please go to student.desmos.com. Don't go to desmos.com. Just go to student.desmos.com. And this is the code that I need you to enter. Lindsay laughs. Okay, so we're going to talk about the activity. We're going to talk about Desmos. What you see in your screen is the teacher dashboard. In other words, what I see. And we're going to do a little tour of the teacher dashboard very quickly. I have the activity here. This is one of the new features. I can share this activity with a co-teacher. We could kind of run it together. It's a bit tricky. Carolyn and I did it the other day. The co-teacher has no power to pace or to do all these activities that we hear on the left, but nonetheless they can follow what's happening. Okay, so if you notice, of course, the names have been anonymized, and I can anonymize them or anonymize them. I can see that. I can also see, even when the names are anonymized, and this is of course just for me, when I hover over a name, I can see who that student is. So that also facilitates me identifying students even when they don't identify themselves, when they don't know. 2 more features right here. One is this: I can sort my students by the time they were active, the time they enter the activity, and this is the default. So I can see who entered in which sequence. I can alternatively, if I need to find somebody, I can sort them by name, and it goes by the first name, right? So these may also give you some information as to when students came. It doesn't give you the time, but it gives you an idea of when students have joined in the activity. So if they're working independently and they tell you they've been at it for a while and they're the last student to come in, you might have a frame of reference there. Okay, and you can also do these and shuffle the order of how the students are shown if you want to, for demonstration purposes. Okay, so the first screen was just an introduction. And basically, this tells you what we're going to be doing, right? Then the next screen, I can see here, I'm going to walk you through what this does. We're going to do snapshots in a moment. I have the summary, the teacher, and the student. I'm going to go to the summary. And this is what I had before. So when I see these, I see everything that is happening in my activity. And it tells me what students are on what screen, what they have done, etc. If I see as a teacher, I can have this view where I have the work from all of my students. I can see them independently, or I can see them overlay. Look at this. Everybody did it correctly, so it seems, very nicely. And if I go to student, I literally see what the student sees. So this is what you, friends, were seeing on screen too. And when you do this, this is what Desmos calls a folder. you open this folder, and then there's instructions here. So I hope you were able to see that. And this activity I created, we had a session the other day on how to do these folders and things like that. When you do, at the end of the session, the feedback, if you think it would benefit you from doing a Desmos Activity Builder session, let me know, and we'll program another one. It's very powerful, it's a lot of fun, and you can get to content that you want, and it's not that difficult. So here, there's a number of questions, right? And this is really kind of like a lesson as to what's happening, right? We are asking students to identify this function and to do a number of things. I can see the work that all my students have done. If I go here, for example, and if I want to go see, I'm going to anonymize this, and I'm going to scramble it to protect the innocent, and I'm going to pick Arthur Cayley. And then I'm going to see what they did. I'm going to go, actually, I'm going to go screen back. And I can see here that this student is following instructions, right? I asked them to label the 2 points, use the values to found, use the x values to write an equation in factor form. So a student can actually do this, f of x equals, and in factor form would be x plus 2, and then x minus 1, right? And when they do that, I can see that. And then I can see, for example, here in my case, my leading coefficient is different from the leading coefficient on the graph, which was done deliberately. Because what we're trying to get at in this activity is this idea of family of functions that have the same intercepts. How are the graphs similar, etc. So these are places where students can enter notes. The same x-intercepts, for example, right? So this is what students are writing, and I'm able to see that live. I'm able to give students feedback, and I'm going to show you how to do that right now. So let's say, hypothetically, that the student, the assignment was given to them 3 days ago, and this is all I have, right? So it's like, this student has been busy, they haven't been able to get it, whatever. So let's say I would just click on this top, and then I can give him feedback right here. And I would say something like, good work on the equation, but the rest is missing, right? And when the student goes into this activity, they will see it. If you're this student, you might see a little notice that just came with this message, and when you click on it, it takes you to that screen. So it's fantastic. Right now, I can see what my students have done. I can give them feedback, not necessarily live. If I want to do it live, I can do it live, which sometimes I do. But if not, even now, I can go back and look at their screens, give them feedback right there, and they can see it. So the screen 2 is really like a working screen, as it were, right? The students are being asked questions and being asked to do certain things. Kind of like a mini lesson, you can think about it, where they are discovering things and they're figuring things out. And then screen 3 is a checking in. The reason I have this screen here is relatively simple. I want to see what the kids have done, and I want to see if they got it right. If they don't get it right, I'm going to see on my screen here something that shows me an X, and that tells me that there's a mistake, or they haven't completed it. So let's take a look here. And for example, here I can see that I need my intercepts to be, or the factors to be x plus 1, x minus 2. So this student might have missed this one, right? Select all that apply. So I may send them a message, or send them a message saying something like, you're missing one. Can you find it? Right? So without really giving the house away, I'm giving them a bit of feedback, and then they can figure out. But that allows me to see what happens. The reason, let me do this. I'm going to on pause this activity. Now, to do the pausing, it's this button here that you see, right, on the teacher dashboard. And now I will choose to
Can I
stop.
interrupt you for one brief second, please,
Of course,
Alfonso?
Michael.
I'm not sure what the protocol is for doing that.
You know
It's
what?
if you
If you
jump
have a
in or
question, no, that's a good point. We didn't specify that, so we're doing two things. You can just do exactly what you did, which is perfect. Just say I have a question, and let us, bring it up. Alternatively, you can put questions on the chat. But thank you for raising it, Michael, and
okay.
we're listening.
All right. So I did put the hand up. I don't know if that's one way to sort of
Yes,
get your
you did, and
okay.
I apologize. I only see some
That's
people
okay.
here, but not everybody.
Okay, so the quick question is, I was looking at the screen just now where you were asking for the input from the students, and it is, well, you can tell me if this is true or not. It is possible for them to delete some of the things that you put into the question section and not get it back. Is that possible or not? Because there are little X's on the side of each of those things that you put
That is
in.
correct. The students can edit the things, and in this case, yeah, they are able to do that. And occasionally it happens. Occasionally
Can
it
you prevent
happens.
that? Because if it was done in error by accident, then they may
Yeah,
lose the
yeah. You know
opportunity.
what? You can see the work that they have done. You can sort it out with them. Depending how far they in the activity, they can go back in. And I like the question you asked, because one of the things that I have done, and one of the activities that I share with you in the collections, is kind of an introduction to Desmos. So students know the difference between entering an equation like I show you. I'm gonna use the screens right now. I'm gonna go here. Um, so for example, here, if you notice, actually, by the way, in this screen, this student, you don't even have to enter f of x. Desmos knows. But um, if a student wanted to, I already programmed this, as it were, to have the right input. There's two types of input, and I'm oversimplifying. There's more than two types of input, but basically the two inputs that are working here today is text or math, right? And if you notice, any time that student has to enter an answer that is verbal or written, there's a space here that says enter a note. So for example, here, how are the two graphs different? List as many differences as possible. They can type text. And question 7 says type a new function in factor form with the same x-intercept, but a leading coefficient of a different value and opposite sign. So here, the input expected is numerical, right? So kids can do y equals -2, whatever, x minus 1, bracket, x plus 2, and then there it is. If they try to enter text here, say something like, I don't get this, you will right away see that they get a warning message, because Desmos is expecting a numerical value or a function or an equation or something like that. And so then it's like, whoa. So to answer, sorry for the long answer, Michael, the students have to understand this, understand how you do this. So I have a couple of suggestions to address that. If your students haven't used Desmos in this fashion, right, which is possible, two options, and you let me know which one you prefer. We can do a short video, or you can do a short video if you're comfortable with, say, something like a Screencastify, where you take the students here and you say, this expects this type of input, this expects this type of input. And then, in a very short video, you can clarify that for your students if you're doing distance learning. I am teaching night school, and I am doing live sessions with Zoom like we're doing now. And that allows me to see what students are doing and give them feedback right there, highlight things. So that's a second option. But the students that I have are familiar already with this method. So I hope this was helpful, Michael. And thanks for the question. That was a very, very good question. Okay. So, and maybe let's do what Michael did. If something needs to be reviewed, by all means do it, and we'll play it like that, make it more organic. So I'm going to stop here. And now, please go to screen 4. We're not going to do anything there. Just go to screen 4. I wanted to show you my screen. Okay. And if you can, oh, perfect, perfect. Go. Just go to screen 4. Don't worry about getting these right. Don't worry. Perfect. I want to show you something. This is exactly what I want to show you. So take a look here. Now that all the students are on screen 4, I can see screen 3, and I can see that there's 2 students that didn't get it right. So this is one possible use of this activity and other activities for evaluation purposes. Say screen 2, we're kind of doing a mini lesson, we're showing something. Screen 3, we're doing a little check for understanding. That check for understanding has a built-in answer key. And don't worry, somebody felt apprehensive. Don't worry about it. Don't worry, this is good. So it's okay. Oh my God, our math teachers want to be perfect. Okay, cool. So I'm going to show you very, very quickly this activity, the responses from an actual class. So you can see here, all the activity has been pretty well completed, but I can see this student has an error on screen 3 here, and then another screen. Do I look at every response at every screen? I don't have possible time because I have 35 students or something like that. However, that's why I have built in these check-in points. And of course, the activity might be a bit lengthy because I run it over 2 classes and the students have time to build it in and we talk about it. So it's not done at once, but this gives you an idea. So I can very quickly see that sadly Leonardo Fibonacci didn't get the card sort. I'm going to show you what the card sort this one didn't get the card sort. This is what the card sort looks like to the student, right? I created this card sort, and it's kind of mean because it has matching graphs with equations with same x-intercepts, but there's also some that are not matched. So it's not, it's a good check for understanding. We can be creative with our card source. Take a look. This student has it perfect. And I know this is perfect because everything is green. I created the answer key. I'm going to go back to this student that didn't get it right. And when I click on the answer key, let me see how come it's not showing me the answer key. When I click on one of these, let me see, hold on just a second. Let me try another one. This one is good. Euclid is good. We wouldn't expect less from Euclid. You can see here, what happens is the first student hasn't even matched anything. They have to bring the cards somewhere, right? And that you can see here that basically anything red is incorrect. So this student has begun to match. They haven't done it fully or correctly, and so on and so forth. Yeah. So this is what you can see, and look at these. Look how friendly I can do these as a teacher, and this is screen 5. And very quickly, take a look. I know exactly who I need to talk to or who didn't get it right. So if I'm using these for evaluation purposes, and I have given my students a few opportunities already, and they haven't done it, well, that's where we are, right? And I have the evidence. I have the evidence. If I mean, and I already gave him enough time, I can pause the activity. And when I pause the activity, nobody can get in. And so, but anyway, so I just wanted to show you what is possible with this activity. Not this one we just did, this one, okay? This activity relates to exponential functions. So this is an activity that you may consider using for your 3U students. It is called Two Truths and a Lie, and this is a Desmos created activity I think is fantastic. So we're going to do the same thing, and I'm going to give you time to, it's basically 2 screens or 3. So I'm going to let you go to the point where you create your own challenge, and there we go. Once you submit your challenge, or at some point, you will be able to see the class gallery. And as more challenges come, you will see these become populated. And what that's doing is a number of things. Um, the students themselves are creating these challenges. So that requires a different level of cognitive ability. It is very easy for you if two students create the identical challenge, which would be very difficult because they're making up the questions, right? And if they do, it's easy for you to realize and maybe call them to task. And in general, they never do this. So um, you have students coming to this activity to consolidate their understanding of some of the key features of exponential functions. And they do that through a very friendly activity at first, that two truths and a lie scenario. And then when they create the challenge, it does require some very good thinking. Awesome. We have 3 already submitted. And then I'm gonna share with you. I'm gonna pause it for a moment, or I'm gonna give you 1 more minute to see if a couple more people want to add, and then we'll pause it after 1 minute to it, and then we'll. Here is what I suggest. This is what I would do if I'm running this activity. First, I pace. If you don't mind looking at my screen, I'm gonna unpause. Don't do anything. We'll just kind of. Don't worry if you haven't finished. No biggie. I'm gonna pace just to screen 1. And the reason I'm doing this is because I want to make sure that the students have understood and have entered the answer correctly. In other words, this is a bit of a check for understanding that they get the first one right. And if you see here, I'm looking under teacher, and my answer key, I click on the answer key, which is already made, and guess what? All my 8 students got it right. Aren't I proud? I'm such a good teacher. So, and then the other answers are there, right? And then people hear the explanations. It's lovely. It's fantastic. So I can, for example, I'm going to show you another feature. So let's say that I'm particularly impressed with this answer. I can do these. I need you to take a quick look at this. I'm going to take a picture, which I'm going to create a snapshot. So I like this one. And he told me that I captured this snapshot. I'm going to go up here and I'm going to pick another one, or down here. I'm going to pick these 2. Okay, I can pick 3, I can pick 4, but I have 2 snapshots. So then I'm going to come here at the top. And when I see snapshots, I have them here. So now, Carolyn's smiling because for some reason they were not coming. I'm going to share them here. Yeah. And then I'm going to present. So if I'm running a small class, or a big class, or I'm videotaping this for my, I can talk about this, right? And say, okay, take a look at these responses, and I can elaborate on it, and look at how these people express the same idea in different ways. X gets larger, Y gets smaller, not larger, so clarifying that. And the Y value approaches 0, which is very beautiful ways of expressing the same idea for this question. So I can do these when I took these pictures, and you take the pictures wherever you see the little camera, and then you have a collection of snapshots, right? And you can put them here, or you can put them back here, right? Pretty amazing. So I want to make sure that my students got this, they got it right. Then I'm gonna stop the pacing. I'm gonna come here. I can see the challenges, and I can see, take a look at this. These student, this is the creator. Here's the challenge they did, and I can check what they did. The y-intercept is approximately 3, and that is the lie, which is perfect, right? Nicely done. What will happen is this. Did anybody get, let me see if anybody got a chance to answer. No, you didn't. When you have, oh, here it is, perfect. Take a look at this. This student created this challenge, right? Identify A as the lie. As the X value increases, the Y value approaches 0, which actually is true, isn't it? So then I may review or whatever. Well, no, sorry, no, the asymptote here, sorry. I'm thinking that, but there's an asymptote at Y equals 2, so that's the lie. Correct, beautiful. And then, oh, sorry, excuse me. I went to this student. somebody answered. And take a look at these very, very, very quickly. The correct answer is A, and this student answered A. So right at the bat, I know that this student got it correctly. So imagine that you have a class with, I'm gonna say 20 students, 25 students. You come to this task, every student creates a challenge. You have 20 unique questions that students created. And more importantly, they go and answer the challenges from their peers. So you could, depends on how much you want them to practice, you can ask them to answer 10. Heck, you can answer them all. But more importantly, you know exactly what they have done. So if somebody, please now, I'm going to anonymize it. Can somebody go into Andrea's challenge, please, and pick answer B, okay? And then we're gonna see what effect that has in our teacher panel. Okay, so if somebody or anybody can go, and I can see here, if you notice, two people have gone into this challenge. I'm getting a lot of information invisibly to the students that is very useful for me. So if somebody can go into Andrea's and pick a wrong answer, that would be awesome. Because then we can see that what happens. Let me see, not yet. Okay, so I like this activity for all the reasons that I just described. There are several activities like this, 2 truths and a lie. They have different content. These are made by Desmos. They're very nicely done. They require a little bit of their computational engine. Now we have 2 answers. No, not yet. Okay, so you know what? That's okay. I just wanted to explain to you what was happening. I hope that was clear, and I hope you enjoy these activities. Very, very, very cool. So we're gonna go out of these, and then we are going to debrief these very quickly, and then we're gonna go to the last part as to how you can access some of these things and just overall discussion. Okay, cool. All right. Okay. All right. So once again, we're back here, and let me see. Does anybody have any comments or questions about this activity or anything you need to do? Okay, Michael Benjamin.
Yeah, I was just gonna say that this kind of, the way in which you're doing it and pausing it as you go along does assume that you have a full class in attendance at the same time. And one of the challenges that we have right now, well, for me anyway, I can't speak for anybody else, is coordinating a time when everybody is going to, you're going to assume that everybody in your class is online and working through an activity with you. Most of the stuff I've done is you sort of do it at your schedule, which is kind of, trying to be flexible because you're finding that kids have jobs now and various other things are going on. So that's the only comment I have.
Absolutely. You know what? Nothing stops you from running any of these activities asynchronous, leaving them for the kids to work independently. Nothing stops you from doing that. So yeah, that is fine. I just have the observation that, let's say, one of the ideas that some people put forward was for teachers to have office hours. If, for example, you run office hours, or you have, again, 20 students or 24 students, and you can communicate to them that there's going to be a live class, and if not, they can see the recorded class. That's fine too. You can record it. You have some kids live, but you don't have to. So to answer your question, Michael, yes, you're right. I'm doing this with us, and partly is because I want to share it with you and see some key points. And part, yes, you can run it like this as a lesson. Do you have to do it like that? Absolutely not. Okay, it's just it's a methodology that might be okay. So I need you to now do something. I need you to go out of this student.desmos.com and go to teacher.desmos.com. And please go to the email I sent earlier. And then when you click on that email on the collections that we send, they will appear on your teacher Desmos account. And then you can just make a copy of them, or you can save them to your own collections if you want. So meanwhile, I'm going to go out here for a moment. This is what you have. The collections that I shared would appear here. And I encourage you, if you have time, to go to these resources for distant learning from Desmos. They are very good. We're not going to do that now, but I just want you to be aware that they are there. The first thing I want everybody to do, if you haven't, some of you already have, so forgive me, those of you who we already did this with, go to where you see your name. And then open this little triangle or arrow. Yeah. And then go to Desmos Labs. And when you go to Desmos Labs, you will see this screen. And I need you to click all of these. In particular, I'll tell you what this is doing for you. If you haven't, you can create marble slides. Computation layer allows you access to kind of a programming thing in Desmos. Don't worry about it, but activate it. There's a beta geometry that people are beginning to use. We haven't touched it yet. I personally think GeoGebra is better. And this is the one we wanted, written feedback. So now that you have done this, save it. Now, every time you give feedback that you give to your students a Desmos activity, you have that button that I showed you earlier to give feedback to your students. So this is important because it's not by default. It's not done automatically. Okay. So here, let me know when you're done by showing me a little thumbs up. I hope everybody got a chance to do that if they hadn't. Good. Good. Yeah. So on your name, open. Perfect. Thank you everybody. So quickly, we have here the activity. So I'm going to go, for example, by the way, I also added a collection of calculus activities for those of you who are teaching calculus. This is how we recommend, and please forgive me if you already know this, but how you want to maybe go about assigning an activity, see what your students are doing. So you have this here, custom. If you've done activities yourself, all your activities are here. If you haven't, that's okay. But you have now collections. And collections, you can create collections that are of interest to you, which is one of the biggest things that Desmos has done recently. All you have to do is new collection and give it a name, give it a description, and create it. I'm happy with my collections. I'm not going to create a new one, but this is how you would do it. And then I'll show you how you add activities to your collection. So let's say that you've looked, and we already curated those. I mean, I have to clarify that the collections that we share with you are by no means all-inclusive. They are by no means perfect. Some of the activities there are more suitable for certain things. So we are sharing these activities, okay? Without any presumption that these will cover your entire curriculum, that this is perfection. Of course, there's many more, but we just wanted to provide some that we've used. But let's imagine that you go here to most popular and that you like these marble slides and you want to add it to one of your collections. All you have to do is click on this plus, and then you can add it to your collection, to whatever collection you want. So let's say for me, it's showing me which collections I already have it, right? So I'm going to pretend that I'm going to add it to grade 10 plus, highlight it and save it. And now when I go to my grade 10 plus collection, this activity is already there. So I'm going to go take a look here, my grade 10 plus. Will it hit the hoop? It's here, right at the bottom. That was one of the biggest things that a lot of us had given feedback to Desmos, that you had everything all in one place. It was mashed up. Now the collections make these fantastic. And you can make a collection within a collection if you want. You can, not a collection, but a section if you want. So if you go to any of our, say, let's go to grade 11, there's beautiful activities here, and you can see where they come from. Here, for example, this is a mini introduction to Desmos to show you the features of the graphing calculator of our students who are not familiar with it. And this is kind of to answer Michael's first question as to you don't want them to erase stuff. You want to know, be a bit Desmos literate, as it were. And there's all kinds of things, right? And so marble slides, if you haven't played with marble slides, are fantastic activities. So let's imagine that I'm curious about what the heck this is. So I'm gonna go here, and I'm gonna see a little description of the activity. A delightful, challenging activity, transform parabolas. Really? Okay, now I come here and I'm gonna do a student preview. And this is what I literally do. And then I go, okay, here's the goal. Get all the stars, get to know parabolas, click launch to see what we mean. Okay, I'm gonna click launch. Okay. Oh, nice, the little stars got hit. All right, okay, I get this. So now I'm gonna come here and I get a question. Change the sign of one number in the row below to fix the marble slide. And if you notice, I have here some teaching moves. And if you need sample responses, right? And in some of these cases, the responses could be multiple, right? Could be more than one answer. So, and they're very well scaffolded. So I'm going to say, what if I make this negative? Okay, cool. You know what? I like this activity. Definitely, it's a great practice for my kids. It can give them a big level of challenge. I mean, I can continue. I can pause whenever I want. I love it. So then all I have to do is create a class code. So when I press this, now the class code is created. All I have to do here is view the dashboard. And then here it is. Here's the screen that you saw. You can put these, share it in your Google Classroom, if you use D2L, whatever you do. I'm going to show you very quickly how you put this in a Google Classroom. So I'm going to come here and I'm going to right click. I'm going to copy. This is the link. Okay, so then I'm going to come and I'm going to go to one of my classes that I have in Google Classroom. Okay, so I'm going to come to this class that is my kind of my lab. I'm going to add it as an assignment. So I'm going to go to classwork, create an assignment, right? And I'm going to call it Desmos, Desmos quadratic marble slide. Yeah. And I don't need to add much else. I would just say to the kiddies, have fun. Okay, and then I would add here, and when I add, I can add the link. I just right click and paste or Control V, add it, and it's done. So when my students come, they will see here the assignment. They click on it, and it takes them directly there. Of course, all of our students must have created Desmos accounts. So that's arguably the first step. Make sure they all have Desmos accounts, and please make sure that the Desmos accounts they have two features. One, that they use our DDSB credentials, the student S000 whatever, and when they log in, they use their actual name. Very important, and you can tell them if you don't use your name, I will remove you from the class, and you can do that easily. Now, so let's imagine that I'm a student. The teacher has assigned me this activity. When I press join, it's going to take me directly there, directly. So I don't need to remember the code, anything. And of course, I can do these in D2L as well. I can put a link directly in D2L in an assignment. The other part I want to show you is this. Many times you'll have students that go, I don't remember the code. I don't know where it is. I lost it. If you direct them to this space where it says see all, when they press this, they literally see all the activities that they have been assigned or they have signed up for. So there's no digital dog that ate the digital Desmos assignment. It's here. So then they can go, oh, I can go back here and fix this. So double bonus, right? Get to the activity directly and kids can see all their activities, but they must have an account. If they try to access the activity without an account, they can do it and they can work through it. You have the data, you have everything they've done, but the data is lost to them. So when they want to go back, they have to start from scratch. So that's why it is very critical that they create the account. And again, you can do these and put it in D2L. You can put it in whatever you want. So this is kind of what we touched on. Let me just check. With the teacher, you added the shared collection. We activated feedback. We show you how to add an activity. We already went over the teacher dashboard, but if there's any other bits of that I have missed, let me know. And then that's why running an activity can be your entire lesson. Michael's point is well taken. You don't have to do this live. You don't have to do this with your class. The students can work on it independently. You have the ability to see who is in, who's not in, giving feedback not in real time, which is fine.